Okay, welcome back, guys. This week we're going to go over some information about circles. There's a few topics that we're going to cover, and then we've got some problems down here where we're going to actually apply a few of these concepts together. So first thing that we're going to talk about with circles is circumference, okay? So the circumference of a circle, it's 2 pi r. Okay, so remember r is the radius. Okay, another letter that we will see is d, and that stands for diameter. Okay, and remember your radius is half the diameter, so r is diameter divided by 2. Okay, or in reverse, the radius is twice the diameter. Or I'm sorry, the diameter is twice the radius. I apologize. The circumference, which is the measure around the outside of the circle, it's kind of like the perimeter of a circle. It's 2 times pi times r. Okay, whenever you have these things next to each other, that means they're being multiplied. And remember, pi is roughly 3.14. Okay, so you can kind of use that approximation if you're having to do some calculations. But your answer might be off just like a little bit, and you'll have to kind of like guess which one it's closer to. So if you can, use the pi button on your calculator. If you have a phone, if you turn your phone sideways when you're in the calculator app, you can get to all the different functions that your calculator has, okay? There's also, and the pi button will be there. We also have a link on the activities page to a free 6-month trial of the TI calculator that's exactly like what we have in class, but on your computer. So be sure to check that out too. Okay, so circumference, 2 pi r. So it's 2 times pi times the radius. Now you have to be careful about your answers. You see here it says leave answer in terms of pi. Okay, that's also known as the exact answer. Okay, so that's the exact answer. Because pi, we don't know all the digits of pi. So if you just leave pi in your answer, that's more exact than getting a decimal that you rounded off. So that's why they call it exact. So circumference. Here we're just going to do 2 times pi and then our radius, which is 9. So 2 times, you're only going to multiply the numbers that are not pi. So 2 times 9, so it's 18, and then you put pi on the end. So the circumference of the circle is 18 pi. Okay, next thing we have, here it says find the circumference of each circle, use your calculator's value of pi, and round your answer to the nearest tenth. So, okay, what we're going to do, and again, it's circumference. So we need 2 times pi, and then times our radius. In this case, our radius is 7. So it's 14 pi. So I'm just going to type this in the calculator, 14 times pi, and I get 43.982, on and on and on. Okay, nearest tenth. That means I have to look at my hundredths place, and if it's 5 and up, I round up. So here an 8, that's definitely above 5. So it's going to make this 9 go up. So the whole thing is going to go to 44. So 44 yards would be our circumference. Okay, question 3. Again, we're still looking for circumference, but this time we have to be careful. They've given us the diameter. The diameter is the whole distance across. Our circumference formula calls for the radius. So we need half the distance. So the radius is going to be this 18.2. And we have to divide it by 2. So we'll get 9.1. Okay, so our radius is 9.1. So now the circumference is 2 pi times that 9.1. Okay, so just, you can type that all in your calculator. 2 times pi times 9.1. Just press enter, and we get 57.176. Okay, again, to the 10th. Here, we have 7. It's going to make us round up, so it's 57.2. So here we go, C. So you have to be careful with the pi, because see here, the 57.8, that's very close. So, you know, try to use the pi button, okay, if you can, but 3.14 is an okay approximation too. All right, next thing. The next thing we have to know about circles is how to find the area, okay? And the area for a circle is pi r squared. So that's pi times the radius squared. And remember, the radius squared, it's radius times the radius, okay? You're just multiplying the radius by itself. But again, if you turn your calculator to the side on your phone, you can get the button to square things. Okay, so here we have the diameter is 10. So I have to find my radius. So I have to do 10 divided by 2, which will be 5. So my radius is 5. So now the area, it's pi times 5 squared. Okay, and again, you have to look at your answers and also what they tell us, leave it in terms of pi. So whenever it says in terms of pi, you just don't put pi in the calculator. So all I'm going to do is 5 squared, which is 25, and then you put pi at the end. So it's 25 pi, and then of course it's area, so it's feet squared. Okay, here, again, we've got find the area, but this time they give us our radius. So area, it's pi times, and then my radius is 3, so 3 squared. So 9 pi. Okay, 9 pi. Okay, this one, again, find the area, and it says use the calculator's value of pi and round to the nearest tenth. Our first one, they've given us the radius here already. So area, it's pi times 11.6 squared. So just type this in the calculator. I put pi times, and then I type in 11.6, and then I press the squared button, enter, and I get 422.73. Okay, and we went to the nearest tenth. So look at the 3. That's not going to make it round up. So it's just 422.7. Okay, problem 7. This was a little different. They've given us the circumference. So they've told us how far it is around the whole outside of the circle here. Okay. Now we can use the circumference to actually figure out what we need to find the area. So remember, your circumference is 2 pi r, and your area is pi r squared. So what we need from the circumference here is that radius measurement. So we're going to have to work that formula backwards so we can get the radius. So I have 12.6, that's my circumference, equals, now we just put the formula for circumference, 2 pi r. Okay, I need to get r alone. So how do I get rid of these two other things here? I just divide by 2 pi. So divide both sides by 2 pi. And that will give us our radius. Okay, so do 12.6 divided by 2 pi. Okay, and make sure if you're doing this on your phone that you put the 2 pi in parentheses, okay, because otherwise it can come out a little weird. So that 2 pi should go in parentheses. So 12.6 divided by 2 pi, and we will get 2.005. Now I'm going to keep those few decimal places just for some accuracy, okay, but it's about 2. Radius is about 2. So now what we will do is go into our area formula. So area, it's pi, and then now we're going to do our radius. So 2.005 squared. Okay, so 2.005, I'm going to square it. I'm going to multiply it by pi. Press enter. And I get 12.62. Okay, so 12.62. So it's about, and again, since we're having to work from the circumference and go back, okay, and they're not telling us how many digits to keep and all this, it's 12.62, so it's 12.6. So on these ones, you just kind of have to look closely, like at which answer is closest. So 12.6. So sometimes your decimal might be a touch off. Just a heads up. All right. Find the area of each sector. Okay, a sector. A sector is just a portion of a circle, okay? It's like a little pie slice, like a pizza pie slice. So to find the area of it, think about it. It's a fraction of the whole area of a circle. So, and it deals with degrees, okay? We can see here, this sector, it's 45 degrees. Now you gotta think about this 45 degrees out of the whole number of degrees that are in a circle. And the whole circle is 360 degrees. 360 degrees, that's the whole thing, the whole circle. Okay, so now basically what we're doing is we're taking, all right, we have 45 degrees out of the 360 degrees, and I want that much of the area of the circle. So you have to think about fraction multiplication. If you want a fraction of something, you multiply that number by that fraction. So for the sector area, okay, so the area of a sector, it's going to be the angle out of 360 times pi r squared. So the pi r squared, that's the area. And then here, this fraction is how much of that area that we want. So here we have the 45 out of 360 times pi times, and then now my radius is 11, so 11 squared. And now it says I want it to the nearest tenth, so I can just type all of this in the calculator and get my answer. So I do 45, and I'm doing this on my phone calculator. So I do 45 divided by 360, and I press enter, okay? And I don't do anything with that decimal. I don't take any places off of it, nothing, okay? Just leave it as is. And then do times, and then do pi, and then times, and I do 11 squared. And then I press enter, and I get 47.51. And I went to the nearest tenth, so here I look at the 1, doesn't make the 5 go anywhere, so it's 47.5 feet squared. Okay, next thing. Find the area of each sector. Okay, now this one, look at your answer choices. You see they're in terms of pi, right? So it's not going to be difficult. I'm just going to have to kind of go do a little extra step for our answer. So again, the area of a sector, it's our angle out of 360. So our angle is 90 out of 360. And here's a hint, guys, 90 out of 360, that's 1/4, okay? It's 1/4 of a circle. So times pi, and then times our radius is 13, and we square it. So, and what you can do, because you see all of our answer choices here, they're all fractions. So do 90 divided by 360, okay? And we get 0.25, which that's 1/4 times pi, and then times, and then 13 squared is 169. Okay, so right now I have 169 over 4 pi. And so I can see here that my answer is D. Okay, but let's say that, you know, you weren't sure how to get this. What you can do is do 90 divided by 360 times 13 squared. Just type this in the calculator. So 90 divided by 360 times 13 squared. Okay, and I get 42.25. Okay, notice I put in everything except for pi. If your answer has pi in it, you have to leave pi out of the calculator. You can only have 1 pi, okay? 2 pi is too much for everybody. So only 1 pi. It either goes in the calculator or it goes in your answer. Can't go in both. So I put everything except for pi in the calculator, I get 42.25. What I can do now is take each of these fractions. So 1445, I'm doing answer choice A. Divide by 6. Do I get 42.25? No, so it's not A. B, 1331 divided by 12. Do I get 42.25? No. Okay. 11 divided by 6. That's definitely not going to be 42.25. Let's see. 169 divided by 4. Right. I get 42.25. So what you can do is, if you're good with, reducing numbers and, getting a fraction from reducing things, do it that way. Okay. But if you're not so good on that, type everything into the calculator except for pi, and then turn all these fractions into decimals and just find the one that matches. Okay, so that's sector. Just remember, a sector is just a piece of a circle. Okay, and here's the formula for sector. All right. Now, this is where it gets fun. Okay, here, these two problems, these are asking us to find the areas of what we call segments. So a segment is this little piece. It's kind of like a little crescent type shape. The way that you have to think about this is we can find the area of this sector, because remember, the sector is just a portion of the circle, like a pizza slice, okay? So we would find the area of this sector, and then we want to take out the area of that triangle, okay? So we want to get rid of the area of the triangle, and that would leave us with only the shaded end part. So to find the area of a segment, it's going to be the area of the sector minus the area of that triangle. And guess what? Fun times are ahead. We're going to have to use some of our special right triangle things to help us find the area of this triangle. Okay, this angle out here is the same as this angle up here. So this angle is 120 degrees. So what we have, and I'm going to concentrate on finding the area of the triangle first. Okay, so this is all the area of the triangle. So this is our triangle. Okay, it's 120 degrees up there. Now, we don't know the formula to find the area of an obtuse triangle. I mean, there is one, but it's a bit complicated. So what we're going to do is actually cut this triangle in half, because the formula for the area of a triangle, it's base times height divided by 2, okay, or 1/2 base times height, whichever way you like. We need to know the height of this triangle, because we can figure out the base here, all right, but we need to know the height. The main thing, though, is on this triangle, this is an isosceles triangle, okay? Both of these sides of the triangle are 2, okay? That's our radius, okay, it's 2. So guess what? If I take this 120-degree angle and I cut it in half, I've created a 30, 60, 90 triangle. So here, this is our hypotenuse, because it's across from the right angle, okay? So that's our hypotenuse. This is our shorter side, and this is our longer side. And remember, from a 30, 60, 90, okay, the short side is x, the hypotenuse is 2x, and the longer side is x square root 3. Now don't worry, it's not complicated. Guys, think about it. 2, our hypotenuse, is equal to 2x, because that's the formula. Well, if 2 is equal to 2x, what is x? X has to be 1, okay? So now that we know the hypotenuse, guess what? We know the height here, so that's 1. And then now, this side down here, it's the longer side, it's x square root 3. So what is x? It's 1, so it's just 1 square root 3. So it's just square root 3. But here's the thing, guys. This 30, 60, 90 is only half of this triangle, okay? So what we want to do is we want to go back here and label this. And I'm going to redraw it here for us, okay? We've just figured out the height of this triangle is 1. And then now we have these two pieces right here that are both congruent to each other. They are each square root 3. So the whole thing Well, I have a square root 3 and another square root 3, so I have 2 square roots of 3. So this is going to be the base of our triangle, and then the 1, that's the height of the triangle. Okay, so now the area of the triangle, it's the base, so 2 square root 3 times the height, which is 1, divided by 2. Okay, now on these ones, the answers, it's going to specify in the problem. You're either going to have to get the exact answer or you're going to have to get a decimal. Okay, so I'm going to leave this as exact for right now, and at the end I'm going to turn it into a decimal. So I'm going to look here. The top is just going to be 2 square root 3. The bottom is going to be 2. Since the 2's are on the outside, they can cancel out, so the area of my triangle is just square root 3. Okay, so the area of the triangle is square root 3. Now what we need to do, zoom in a little bit, give us some more room, is find the area of that sector. Okay, so the area of the sector, it's the angle, so 120 out of 360 times pi times r squared, and our radius is 2, so 2 squared. So now 120 out of 360, that's 1/3. So I have 1/3 times pi times, and then 2 squared comes out to 2 times 2, which is 4. So I multiply this, I get 4/3 pi. Okay. All I did was multiply the 4 times the 1/3, that's 4/3, and then the pi comes along for the right. So now we have the area of the sector and we have the area of the triangle. This guy here and this guy here. And now to go to our formula, the area of the segment, remember we have to take the whole area of that sector, and then we want to get rid of this triangle, and that'll leave us with the shaded part, the segment. So area of the sector, 4/3 pi. So the area of the segment, it's 4/3 pi minus, and then now the area of the triangle is square root 3. Okay, and if I wanted exact, I'd leave it like this. Okay, if I want the exact answer, I have to leave it like that. I know it looks ugly and weird, but that is the exact answer. But a lot of times on this, we want it rounded to the nearest 10th. So I'm going to type this in my calculator. Do 4 divided by 3, and press enter, times pi, enter, okay, minus, and then I do square root 3, enter, and I get 2.45, so that's going to round to 2.5. Okay, so we have the exact answer, and then we have the approximate, the rounded answer. So yes, it's a couple steps, but as long as you remember your 30, 60, 90s, it shouldn't be too complicated. Okay, again, watch this part over and over again if you need to, but this is kind of like the most complicated 30, 60, 90 that you're going to get. The other one's not going to be complicated at all. All right, so now moving on. Okay, let me pause for just a second. Okay, so we're back. Sorry, I had to rearrange a couple of these problems just to give us a little more space. Okay, now this one here. On this one, we kind of have to think in reverse. We have to think, okay, I want every part of the circle except for the little segment right here. Okay, so what we're going to do is we're going to do the area of the circle. Okay, and then we're going to subtract the area of that segment. And then you have to remember, the area of the segment is equal to the area of this sector. Okay, area of the sector minus the area of that little triangle. Okay, now this is not the only way that you can approach this problem. There are several different methods that you can use, but I'm trying to use like as a framework to kind of help you guys. So we want the area of the circle, and we're going to take out the area of the segment. And the area of the segment, which is this little piece I'm coloring in purple, okay, that's the sector minus the triangle. Okay, so we're going to first start on that. We're going to find the area of the segment. So we have to look at our sector. Okay, the angle here is 90. So the area of the sector, it's going to be 90 out of 360 times pi times, and then our radius is 12 squared. Okay, and we already know this is 1/4 times pi, and then 12 squared is 144. Okay, and if you do 144 times 1/4, you get 36. So the sector is 36 pi. Okay, that's just me doing 144 times 1/4. So 36 pi, that's the sector. Now the area of the triangle. Okay, this one is easy. 12 is our base, but over here 12 is also our height. Okay, the base and the height of the triangle, they're interchangeable on this because it's a right triangle. So the area of the triangle is going to be 12 times 12 divided by 2. So 144 divided by 2, which is 72. Okay, so now the area of the segment, it's the area of the sector minus the triangle. So the sector is 36 pi minus, now our triangle is 72. Now I'm going to leave it like this because I want the exact answer. Okay, I want the exact answer. So do not type any of this in the calculator and try to get a decimal. You're going to miss a whole bunch of information. Your answer will be incorrect. So 36 pi minus 72. Okay, because you also have to look at the formatting of your answers. On the quizzes, all of these are multiple choice. So you're going to have to look at the format of those answers. So now to get our final answer, we have to do the area of the circle. So the area of the circle, it's pi r squared. So pi times 12 squared. So 12 squared is 144. And we have pi. So now the final answer here. Okay. We have to do 144 pi minus, and then now we have to do the area of the segment. Remember, the area of the segment is this whole thing right here. I'm going to put it in parentheses. 36 pi minus 72. Okay, now I'm going to multiply this negative sign into here. So I have 144 pi minus 36 pi. And then a negative times a negative, that's plus. So plus 72. And so now I'll simplify. I do 144 minus 36, because those both have pi. They have pi, you subtract or add. Okay, it's combining like terms. So I have 108 pi plus 72. So 108 pi plus 72, this is the exact answer. And then if you want to get the rounded one, just do 108 times pi and then add 72, and you'll get 411.3. And that's the rounded. Okay, next one. This one, they're going to ask you to find the area of this shape, and you have to be a little bit careful. It's not just the area of this circle and then the area of this sector added together. That's the basis of it. But if you did that, you would end up counting this little part right here where they overlap twice. So what we have to do is we have to find the area of the small circle, add to it the area of the big sector, and then we have to subtract out the little overlapping part. Okay, and we have to subtract out the overlapping part because When we find the area of the circle, that's the area of the whole circle. When we find the area of this sector, that's the area of the whole sector. So we've counted this little tiny sector here, we've counted it twice. So we have to subtract it out once, so it's not double counted. So there's 3 areas that we have to find, and then we add 2 and then subtract the other one. So start off with the easy one, area of the small circle. It's pi times the radius squared. Now here, this is our radius. It's from the center to the edge of the circle. So it's 2.2 squared. And I'm keeping this all in terms of pi, keeping it exact as possible until the end. You always want to do that. So do 2.2 squared, and you'll get 4.84. So 4.84 pi. Okay, that's the area of the small circle. Now we need the area of the big sector here. So the area of the big sector. And it's a sector, so we have to do the angle, which is 56.8 out of 360 times pi times, and then our radius for this is 12, so 12 squared. So again, I'm going to type in everything except for the pi. Okay, so we get 56.8 divided by 360, press enter, times, and then 12 squared. And so I get 22.72, and there's a whole bunch of zeros and a number at the end, but 22.72, that's good enough for our needs here. So that's the area of the big one. And now we need to find the area of this small little sector, okay? With this here, the angle that's over here on this side is going to be the angle that's here as well. So we have 50, let me label here, area of the overlap. It's 56.8 out of 360 times pi. And now here, our radius of the small circle, it's 2.2, and square it. So again, I'm going to type in everything except for the pi. So 56.8 divided by 360 times 2.2 squared. So we get 0.7636, okay? But again, look, since we only are carrying around, oh, and I forgot to add here the pi, didn't I? Okay, we're only carrying around to the hundreds place, so it's 0.76 pi, okay? So now what we will do is we'll follow our little formula. We have the area of the small circle, so it's 4.84 pi plus the area of this big sector, and that was 22.72 pi. And then now we have to subtract out the overlap, so minus 0.76 pi. And what I'm going to do is I'm going to go through and I'm going to take care of all just like the decimals, and I'm going to get it in terms of pi first. So 4.84 plus 22.72 minus 0.76. Okay, making sure I entered this in correctly. All right, enter. And we get 26.8, and then it's still pi. So 26.8 pi. And then now, in order to get our final answer, I'm going to do times pi. So 26.8 times pi. And we get 84, and it's 0.19. So it'd be 84.2. So if they ask you for the nearest tenths, it's 84.2. If they ask you for the exact, it's 26.8 pi, about. So there's that one. Just with these kinds of problems, you have to think, okay, what do I need and what do I need to like get rid of? Like, what do I not want to double count? So anywhere that they're overlapping, you have to subtract that out at least once. Okay, now this one, they're going to ask you to find the area of some kind of composite shape here. We only want the shaded portion. So I can see this is a square. I have the overall big shape is a square. And then I need to get rid of these 4 quarter circles, okay? So I'm gonna have the area of the square minus 4 of the area of the quarter circle, okay? So first things first, this 14 is only from here to the center. This is where the 14 is. So the whole side of my square, the whole side is 28, because 14 times 2. So the area of a square, it's side squared, and so it's 28 squared. So 28 squared, that's 784. Okay, that's the area of the square. Now the area of the quarter circle, okay, it's pi r squared divided by 4. Okay, so we have pi times, and then now the radius, okay, the radius of our circle is just from the corner of the square to halfway. So the radius of our circle is 14. So 14 squared and divided by 4. So 14 squared is 196. Divide that by 4, and you get 49. So it's 49 pi. I didn't put pi in the calculator, okay? Because again, it will depend upon whether your problem is asking for the exact area or for a rounded area. So you have the area of the square and the area of the quarter circle. So now we just go here. Area of the square is 784. And then I need to get rid of the 4 quarter circles. And so the quarter circle is 49 pi. So now 784 minus 4 times 49 pi. So it'd be 784 minus, and then just do 4 times 49, which we should get out 196. Okay, so this right here would be the exact answer. But if they want the rounded one, just do 196 times pi. So 784 minus, and then I'm going to put it in parentheses, 196 pi. And I would get 168.25. And that would be the rounded one. And that's rounding it to the hundredths. Rounded to hundredths. Okay, it'll just depend on the problem. So just with these kind of compound areas, you have to think, okay, what is the big shape and what do I need to get rid of so that I have the little shaded part? So you're always trying, there's always going to be some kind of subtracting in any shapes that are overlapping. And there's going to be some adding usually too, if you have like this kind of combo type shape. So if you aren't sure of, you know, a problem that you get, you know, kind of like shade, like use a couple different colors to help you. So you can see, and like always, if you have any questions, just feel free to reach out and let me know, and I'll help you out. See you guys later.